Hi everyone. So we're going to have a seminar for the upcoming Formosat 8 mission. So we are very delighted and happy that we can invite the project, the PI, principal investigator of the entire mission of the Formosat 8. That would be Dr. Chen, Chen. And the follow up the talk will be the two main payloads for the Formosat 8 first satellite and the Formosat 8 second satellite, which will be the a study of the couple of the atmosphere, electricity, ionosphere, and the high energy physics. And the other one will be the gamma ray payload. So we will start the first by the talk given by the guy of the Formosat 8. So let's welcome Dr. Chen to present his talk.
Thanks to Professor Lin's introduction, and welcome everybody. Today I will briefly introduce Formosat 8 program. Yeah. Today my topic will divide it into 4 categories. The first one is I will briefly introduce the background of NSPO, and then I will introduce Formosat 8 program features and then the current status. And in the last, I will give you a summary. And okay, NSPO, the role and responsibility in Taiwan. We are the National Space Agency in Taiwan, and we are also in charge of the space technology R&D activity. So you can see in this chart, the Formosat 1, that's the first satellite developed in Taiwan, was launched in 1999, and Formosat 2 was launched in 2004, and Formosat 3 in 2006, and then Formosat 5 in 2017, and Formosat 7, that's also Cosmic 2 in 2019. And in this chart, you can see our in NSPO developed phase. We have 3 long-term space programs. The first phase started in 1991 and to 2006. So in the first phase, we have 3 mission satellites. The first one is Formosat 1. It's a science satellite, science mission, and it was launched in 1999, and the mission ended in 2004. And then Formosat 2, it's a remote sensing satellite, and it was launched in 2004, and the mission phase, it took a longer time, so it ended in 2016. And then Formosat 3, it's a meteorology and science satellite. It was launched in 2006, and right now it's out of phase. And so in the first stage, our mission, we just not develop the satellite because it's the space technology it's a brand new area in Taiwan. So it's very important to develop the infrastructure. So we have the INT facility building established in this space. We also have our ground receiving station, and also the image data processing center developed in this phase. And it's very important to have the satellite. We said we have developed our satellite development team, and because before that, before this phase, we didn't have any satellite engineer, satellite area expert in Taiwan. So we have a core team, and we send the core team to our partner. For example, like the Formosat 1, the prime contractor is TRW. So we send our core team to TRW to work together with them and to build up the satellite developed capability. And in Formosat 2, we have prime is at that time the name is Matra Marconi, and then it's Airbus. And we also have a core team to work together with their engineer. And in Formosat 3, we have the prime is Orbital Science. And so we work together with Orbital Science to develop the Formosat 3 program. And then started from 2004 to 2018, we call that's the second space long-term development program in Taiwan. And in this phase, we have two major missions. The first one is Formosat 5, and then Formosat 7. And Formosat 5, that's the first satellite fully developed by Taiwan. And it's a remote sensing satellite. Of course, we also have the science payload on it. And it was launched in 2017. And Formosat 7, it's a follow-on mission of Formosat 3, and it will launch in 2019. And besides that, we also have the sounding rocket mission program, sounding rocket program. And in this program, we also have several science missions on it. And so between 1998 to 2014, we launched 10 sounding rockets, and 9 out of 10 were successful. And also, starting from Formosat 5, NSPO developed some key components and for the satellite, not just the payload, but also the bus unit. And okay, and the third phase long-term space program started from 2019. It was approved by our government in January 2019, and Formosat 8 is the first mission program in the third phase space program. And so in this chart, you can see we are going to have 3, we call that main missions in this phase. The first one is Formosat 8, and it's an optical remote sensing satellite. And the second one, the name was not formally titled yet. And it's a high resolution remote sensing satellite. And in Formosat 5, we have 1 meter resolution, and the follow-on mission, we would like to have better than that's important because the submission, because the optical payload will be impacted by the weather. If the weather is not good enough, and then we cannot take any image but the SAR satellite can overcome that kind of issue. And so in the bottom, you can see we have B5G communication satellite that's beyond 5G satellite. So that it was a new, it's a top-down mission by our government because right now there are a lot of LEO communication satellites under development. So our government, we would like us to also develop this kind of capability and also include the local industry to get involved in this program. And so in third phase space program, we have a mission from our government, not just only focus on the remote sensing, but also we will be asked to promote the local space industry. So how to do that? And so in this chart, the left-hand side, you can see in the past, we got a mission from our government. And so we need to develop the new satellite to meet the national need. And so it's very difficult to have to do that in one step. What I mean one step is if we have the new component, new technology, and we want to do it once and successful, it's very difficult and it's very challenging. So the right-hand side is our current approach. We are going to develop we call that generic bus platform. In this platform, we have a lot of new components and new technology, and but we try to do that in cost-effective way. And later on, I will briefly introduce that. And then we can have low cost for this bus platform. And we will do the flight demonstration of that platform and also to verify our new components and new technology. And after the flight demonstration, then we have more confidence on that. Then we will use that platform to do the national mission. And so it can break down into two steps. And the first step is to have low cost and to try the new component and new technology. And the second step is to have to meet our national needs with low risk. Okay, so before we make the decision, we do some trade-off on our platform size. And as you know, there are a lot of different kinds of satellite platform, like the CubeSat platform, microsat platform, and small sat, and the large satellite. And they have different kind of performance. And if we want to get the excellent performance, the satellite should be very, very huge. And if we want to have the very cheap approach, then CubeSat is a good choice. And so, because as a national space organization, we are thinking about which one should we choose, and the small set or microsat, maybe that's the balance between the performance and the cost for us. And the other one is from launcher point of view. There are many new launcher this years. And we have the large launcher, and they can have share rights on the satellite. And we also have a lot of small new launchers. They can provide dedicated launch service. So it looks like if the satellite is not large, for example, like a small sat or microsat, we will be very easy to have the launch service, no matter what large set launcher or small launcher. And the other one is we would like to have from the mission point of view, we would like to have, for example, like the remote sensing mission, the constellation, the local revisit time is also very critical. So the constellation approach is very good, and it can provide the good spatial coverage and also temporary revisit with the constellation. And the small sat or microsat, the cost will be also lower than the large satellite. Yeah. So the Formosat 8 program features, the first step is we are going to develop the generic bus platform. And we will also like to use that platform and can be expand to the other follow-on missions. And in this platform, there are more than 85% key components developed in Taiwan. And so that can help the local industry to get involved in space industry. And we choose the cost approach. So the platform, the cost is affordable. And the risk control, because if we want to do everything brand new, and that means it will be high risk. So in this platform, we try to use we call that redundant design. For the key components, if we have the brand new component, then we would buy another flight heritage component installed together. So if the brand new one have some malfunction issue, then we will switch to the redundant one that have the good flight heritage, and that can reduce the overall program risk. Okay, so the bus platform evolution from Formosat 5 to Triton, and that's also another satellite developed in NSPO. Then the Formosat 8 program, it's a generic bus platform. And then after that, you can see we have a B5G communication satellite, SAR satellite, and very high resolution satellite. And we would like to use most of the components as the same design as Formosat 8. So it can speed up the satellite development. And it can also reduce the risk to develop a brand new satellite. And as you know, in Taiwan, we have very good ICT industry in Taiwan. They have very good mass production capability with very good quality and low cost and very fast delivery time. And they also have very good flexibility for the customized design. And so we are going to have the more and more local industry companies to work together in our third phase space program, and because they can provide the good quality and key component for our mission, but not just for NSPO satellite. In the future, they can provide this product to all over the world. And so, what's the gap between the right now this local industry company and if they want to deliver the space qualified product? As we know, they are lack of the design heritage for the flight component, and they don't know what's the manufacturer standard, what's the testing standard for the flight units. And so NSPO can provide this kind of service to them, to help them to develop the space qualified components. And the most important thing is if they pass all the tests, verification, and then we will install that component on our satellite to do the flight demonstration to verify their performance. Yeah, so it's very important to work together. Yeah. So because in Taiwan in the past it's very difficult to know the how to verify the satellite components. And then we have a union to Taiwan Space Radiation Environmental Testing Alliance. We invited several organizations like the Chang'an Memorial Hospital and Chang'an University and Institute of Nuclear Energy Research, and also the private company Integrated Service Technology. They are quite famous in the component verification and testing. And also academic Sinica and National Tsinghua University to join this alliance, and we can provide the radiation test service for the local industry, local company, or any university if they are going to verify their component or parts, if they can sustain, if they can survive in a radiation environment. So you can see there are several the facility in Taiwan. We can do that. Okay, and this slide just show you the satellite performance evolution from Formosat 5 to Formosat 8. We have the better resolution. In Formosat 8, it's 2-meter resolution, and in Formosat 8, it's 1 meter. And also, we can enhance that after ground processing to 0.7 meter resolution. And the size and volume is smaller than Formosat 8, and it's lighter. And we have a good uplink TT&C capability. and also expand downlink capability, and the propulsion performance is also better. Attitude control capability is also better. And the flight software in Formosat 5, we can only do some code patch for that. But in Formosat 8, we have the capability to upload the 100% brand new code for the flight software if that's necessary. Yeah. And here you can see if we take a look at of the GSD improvement, the left-hand side is a Formosat 2 picture of the airport with 2-meter resolution, and right-hand side is 1-meter resolution image. So we can provide a better image information to the customer. And this slide just would like to tell you in the multi-spectrum band, in the past we only have 4 bands, the red, green, blue, and near IR. And in Formosat 8, we have 6 bands. So in addition to 4 bands, we also have Red H1, Red H2, these 2 new bands. And these 2 bands can do very good information, provide very good information for agriculture study. Okay, so what's the current status of Formosat 8? In 2019, Formosat 8 just passed the critical design review. And last year, in December, we just finished the INT readiness review, and we are going to integrate the satellite in this year. And so the first satellite are going to be launched in 2023, and the second satellite will be launched in 2024. Okay, and because there are a lot of key components, and so you can see we have many optical components like the mirrors, filter, corrector lens, and focal plane assembly, the electronics unit for the optical payload, refocusing mechanism, and CFRP structure for the optical payload. And we have the expand transmitter and expand antenna. And also we have the propulsion system that's hydrogen peroxide green propulsion system and deployment mechanism. And in Formosat 8, the first satellite, we are going to have a science payload that's a dual band imager of atmospheric transient and electron temperature and density probe that's developed by NCKU team. And the Formosat 8B, that's our second satellite. We are going to have the science payload, gamma ray transients monitor, GTM, developed by NTHU team, National Tsinghua University. Okay, so I make a summary. The Formosat 8 is the first mission satellite in three-phase long-term space program. And so it's very important and very critical because we also have a mission to promote the local space industry. And so our approach is we will have a generic bus platform to carry more than 15 domestic components for the flight demonstrations. And besides the remote sensing mission, we also have the dedicated science payload on each satellite. And we are going to launch the first satellite in 2023 and second satellite in 2024. And we are going to expect to have the remote sensing image data and science data after 2023. Yeah. Okay, so that's all my presentation. Thanks for your patience. Thank you.
So you mentioned that the first F8 Formosa 8 would be launched in 2023, the second one in 2024, right?
Yes.
And then following them, there will be another 4 or 5, the same 4. So therefore, we have 6 satellites.
Yes.
And what would be their constellation, the orbital configuration? I mean, how do you mentioned it's very important to have a constellation.
Yes.
Yeah.
Okay. Yeah, that's a good question. So for more, due to the remote sensing mission, we have that's a sun-synchronous orbit, and the orbit height altitude is 561 kilometers, and it's a daily revisit mission orbit, and so we plan to have 3 satellites to provide the global coverage. So 3 satellites will be in different orbit track, and the other 3 satellites will be at the same altitude, but the local revisit time will be different. The first 3 satellites in the daytime, in the morning time, it's around 10 to 11 o'clock, and the other 3 satellites will be in the afternoon. Yeah, at this moment we plan to arrange the time maybe 13 to 14 the duration. Yeah.
And what is the advantage of this kind of constellation formation to the other constellations?
Okay, so are you asking?
I mean,
what's the advantage of this kind of constellation?
I mean, there are also other optical observation constellation, you know, from other agencies.
Yes.
So there are 2 questions actually. So one is that what is the uniqueness of this F8 mission? And one is that how would the F8 missions how to say that to combine with other missions to optimize your results?
Okay. Okay. The mission, I would say the first one is because we got the funding from our government, so we focus on how to create the most important information to meet national need. And so the first 2 satellites, the first one is the daily revisit. Okay, for the other satellite, remote sensing satellite, they choose not daily revisits. Because they want to have uniformly distributed on the whole world to take the image. But the daily revisit, we would like to focus on Taiwan. Of course, they can take the image on the other area, but the repetition rates on Taiwan will be higher. Yeah, and so this one is important for us. Yeah, and the daily revisit, if we can come here, visit the same place at the same time, then it's also important for the users. They can analyze their data because they are under the same condition. Yeah. So it's also important. Yeah. And if right now, Formosat 8, we can provide 1 meter panchromatic image. And after ground processing, it will be 0.7 meter image. And that should be good enough for most of the application. And if, for example, if someone wants to have a very, very high resolution image, like the 0.3 meter, then they can buy that from the other companies for that. And so our goal is we can provide the image daily image, and if so that can provide the more information, more frequent information to the users. Yeah, if we only have one satellite, then it's very difficult to provide the multiple revisit satellite image to the users.
Yeah, thank you. Anyone in the audience have questions to ask Dr. Chen? I think it's a very good opportunity to ask more information, get more information on this very interesting Formosat 8 mission. And we just talked about the orbital configuration, the advantage of such a constellation, and of course the filter. I mean the filter set, as Dr. Chen mentioned, is also partly is to specialize in agricultural applications. Dr. Chen,
yes,
thank you very much for this presentation. And then I think the last part about the, I mean, you only mentioned about this first two satellites. So I would be very interested in knowing, after you have all 6 of them,
okay.
and what will you do? I mean, what kind of magical stuff you could perform? Yeah.
Yeah.
And when will be the last satellite? And the number 6, when will that be launched?
Okay. After right now in our current schedule planning, after 2023, we will launch each satellite, one satellite in each year. So from 2023 to 2028, each year we will launch one satellite.
Very good. And I suppose that you would call for a proposal for the scientific experiments. Otherwise, you're going to have the same instruments on every other satellite.
Yes, we will. Yeah, we will call for proposal for that. Yeah.
And would you, because for the current two satellites, you have very limited resources for the scientific instruments.
Yes.
I mean, I remember it's something like 3 kilograms or something, right?
Yes.
And the idea is that because it's a prototype, you think that you want to test, but once you know the satellite better, you could embark on the installing bigger scientific experiments.
Yes.
And giving them more mass and more capability.
Yes.
Correct.
Yeah. Yeah. Because at that time, I should say in 2019, we did not take the sufficient information about the launcher capability, because it also highly depends on the launcher capability. and so we are more conservative on that. Yeah, and in the future, I believe after we figure out what's the launch service capability and also our satellite, the size and volume and the mass capability, then we can provide the better information for that. Yeah.
That's good, because now that you're limited only one instrument on one payload, one scientific payload on each satellite.
Mm-hmm.
I think in principle, once you become more liberal, you know,
mm-hmm. Yeah,
no longer that conservative,
mm-hmm.
and I could imagine that you would be able to produce a platform for multiple instruments.
Mm-hmm.
I mean, not just one, but maybe two or three.
Yeah. Mm-hmm. Yeah.
And to do that, one may have to plan, you know, so how to say, to make some feasibility study ahead of time.
Mm-hmm.
I mean, of course, together with you, you know, because only you knows the engineering, you know, condition.
Yeah. Yeah.
And for instance, if you're talking about number 1, number 2, but when we say, hey, number 3, number 4, even thinking about number 5, number 6.
Mm-hmm.
And, so one could use for number 3, number 4, we want to start thinking about the scientific payload now, you know, what to do.
Yeah, yeah, we will do that. Yes. Yeah.
So we'll be happy to, you know, I mean, I'm sure the scientific community will be very happy to work with you, you know, because it's to their advantage and also to your benefit also.
Mm-hmm. Okay. Yeah, that's a good suggestion.
Yeah, because if this constellation, besides for Earth observations, for science, it also is a very important, you know, important communication. Okay,
so I turned myself to the cell phone. Sorry, I was silenced because my laptop's microphone was dead. Also, I also have a question that you mentioned that the NSPO want to make a series of a prototype, like a mass production of the bus, so that they can make the satellite mission quicker. Also, are you going to produce only this kind of size of a bus for all, so that the capacity of the putting the payload will be smaller? Does NSP also have a plan to produce a larger satellite in the mass production, or you just right now want to do what you have right now?
Okay, that's a good question. It's a trade-off. To be honest, we think about from the beginning, Formosat 8, the size and volume is not what you look now, and it's smaller and it's lighter, and but we do several kind of trade study, and finally it grew up, and so because the size and mass will impact the launch service, and that means that will impact the cost, and we try to optimize that. Yeah. And so right now I should say we have the capability to expand the satellite volume, but the impact will be the schedule and the cost for that. Yeah, but in NSPO side, for example, like the B5G, the communication satellite, as I know, their bus platform is a little larger than Formosat 8. Yeah.
Thank you so much. So I think that'll be the end of this presentation. Thank you again for Dr. Chen to spend. I know that you're very busy and willing to spend the morning to talk about this, and everybody's has a lot of expectation on this mission. So thank you so much for joining, and looking forward to your successful mission. Thanks.
Thank you all. Yeah, thank you.
Thank you.